Hello there, my name is Noah, and I'm here alongside my co-hosts Em.
Hey.
And Rob.
Hey there.
We are the hosts of Fax Machine, a podcast by and for people who are curious about everything, but especially the things that make them laugh. We are so excited to welcome our special guest, Dr. Latasha Wright, to this episode. Welcome.
Hi! Hello, everyone.
Hello, welcome. So, Latasha, you are the Chief Scientific Officer at BioBus, and astute listeners will recall that our very own Rob Frawley is a scientist at BioBus, making you Rob's BioBus BioBoss, which is how I'm going to be referring to you, if that's cool with you.
I kind of like Boss Babe, but if you gotta go there.
There we go.
Why not both? Why not BioBoss Babe?
Ooh, BioBoss Babe. I like it. Okay.
Nice.
Yes. So I'm gonna get cards made up with that.
Absolutely.
I was gonna say this is definitely following us back to the office.
I know.
Yeah, so we're extremely excited for you to be on because you're a very cool scientist who's got a lot of cool stuff to tell us, as we know. But I've also been wanting to learn more about BioBus, and Em, you understand, Rob has been trying to talk to us about BioBus for ages, but we were kind of holding out for someone more prominent, maybe someone a little higher up in the organization who could give us the real scoop, So now that you're here, we're finally ready to ask, what is BioBus?
Well, BioBus would not run without Rob. We need him. He's like, he's the linchpin,
He's got to talk to the computer.
No, so we've been around since 2008. And we started out with a 1974 transit bus that was bought off of Craigslist for $10,000.
Heck yeah.
And then we got a bunch of microscopes and we put them inside and we took it to schools and communities, and kids loved it. And it made such a huge impact that we were like, okay, we got to keep going with this. And so we decided to abandon ship on the academic front and then just go ahead and be driving education.
Very nice.
Yes.
Drove education to all the schools and communities around New York City. So we've had over 300,000 kids come on our BioBuses in the last 12 years. So the kids can come aboard and do science with us, but we also have a bio base in Columbia Zuckerman Institute, where people can come and do after-school programs. And we also have internships for high school and college students. And once we get back in person, you can definitely come to our public events and that are held monthly. And you can definitely see Rob there because Rob's there all the time. I'm like a slight stalker of Fax Machine, then you can come on out. It's really great. I love it. I think that the kids make me understand why I wanted to go into science, because they see the curiosity that you see, and also the excitement that just seeing something like pollen under the microscope, you're like, oh wait, this is amazing. So it makes you really understand how wonderful the world around you is.
Absolutely. I think microscopy is one of those things that I have to do for my job as a scientist, but I spend more time on the microscope than is really necessary, because I just get utterly lost in being like, whoa, neurons look like what?
I know, exactly.
And it's so fun to be able to see these incredibly small, very, very interesting things. And it's really awesome that you've given kids a chance to experience that as well.
Yeah.
So if you like what you're hearing about BioBus, an extraordinary organization we have just learned about today for the first time, If you wanted to donate to BioBus, you could do so at donate.biobus.org, and we will give you that link again at the end. But just in case, as you're listening to this, you're like inspired to help some kids learn about some science on a bus, as opposed to any other place. It's a great place to learn about science. You can go on your phone that you're listening to this on, maybe, and donate at donate.biobus.org. All right, so in every episode of Facts Machine, each of us shares one fascinating fact along with the incredible story behind it, and finally we wrap things up with a pub-style trivia quiz loosely inspired by the theme. And this week, our theme is dyes. Those are substances used to impart color to materials such as textiles, and which have had remarkable impacts on the course of history, science, and art, and we are dying to tell you all about it. Okay, look, don't let jokes like that one color your expectations of what we're sure won't be a stain on our record. But although we recognize that describing colors on a podcast can be a challenge, you'll have to take our word that these aren't just pigments of our imagination.
Damn it.
Yes, there's no doubt that the facts we share in this episode will be intense.
Ooh.
Noah,
Yes.
who do you think you are?
I mean, what did you expect, Tra?
Very good, very good. With that, Em, take it away.
All right. Happily. All right. This week, I learned that the first synthetic pigment ever made has given us, among other things, Hokusai's famous The Great Wave off Kanagawa woodblock print, cyanide, and a life-saving medication that gives your poo the blues. Yeah, quite a motley crew, or I guess motley blue, of functions. So, yeah, as you've probably guessed, I'm talking about a blue pigment, or dye, depending on how you apply it, and that pigment is called Prussian blue. So I will say that before I launch in, quite a bit of what I'll discuss in this fact I learned from Cassia St. Clair's book, The Secret Lives of Color, and I highly recommend it. It is just, if you ever want to delve into the kind of like cultural and scientific and historical significance of all sorts of different colors and pigments, it is just a really like delightful compilation. And it's also just like graphically presented as a rainbow, like on the border of each page.
Oh, cool.
So it's just very pretty to like flip through as well. Anyways, a bit about humanity's relationship with the color blue before I launch in. So across centuries and civilizations, blue is ubiquitous and imbued with myriad meanings and associations. It's
Too good.
not seeing the end of
That's
that.
staying in.
So, for example, like in the religions of the ancient Egyptians and Hinduism and Christianity, blue has been associated with the heavens and divine figures. It's featured in regalia and coats of arms of royalty, kind of giving it a significance of like sovereignty and nobility. And honestly, even beyond that, blue's connotations are so numerous that they can even be like contradictory. It's at once the shade of kind of like melancholy and sadness, you feel blue. It's also kind of like associated with like order or respectability. We think of sort of like military outfits kind of being frequently blue or shades of that. You have blue bloods of the upper crust, but then also like blue collar manual laborers forming unions. So it's just, as I mentioned, ubiquitous everywhere. We think about blue a lot all over the world. And even nowadays, if you just Google search like associations or connotations of the color blue, pretty much everything that comes up has to do with corporate branding because, of course, it does. But some of the words that you'll see are like peace and calmness and freshness and purity and health and wisdom and trustworthiness. And it's just, it just can mean everything and anything. And is also, I think in surveys, the most common favorite color of just people across surveys.
That's me.
Fair enough. Yeah.
Same.
There we go. Oh my God, look at that. And so, is also a very common kind of like safe choice. among corporations, which is also why, at least I feel personally, when I'm on my phone, I like regularly try to like tweet from the Facebook app or hop onto a Zoom meeting in Zillow or like accidentally Venmo people when I'm just trying to check the weather. That last one has really wreaked havoc on my bank account. But point being, just like
trying to Venmo your weatherman to
yeah.
come on, I'm really hoping for some rain tomorrow.
No, like please give me warmth, please. So we, as far as I can tell, like humanity has always craved blue. And given this sort of desire for blue pigments, in art, crafted objects, textiles, for much of history, blue pigment was actually often really rare and expensive and not easy to obtain. So if you were an artist at the beginning of the 18th century in Europe, which is just before Prussian blue, the pigment of my fact, kind of came onto the scene, the blue pigments available to you were all derived from nature. In most cases sourced from like foreign faraway lands, imported quite a long way, and then only actually isolated after labor-intensive and in some cases like chemically toxic processes. So, for example, one of your options was indigo. That's, a dye that we've used across cultures dating back to antiquity. The best quality versions of it are derived from leaves of the Indigofera genus of plant that's found in tropical and like subtropical climates all over the world. Though there is kind of like there was like a not as color fast version from a related plant called woad in Europe that became a little more popular around this time as well. But even still, like the process to derive indigo, like as a powder for a pigment, involves fermenting the leaves of this plant in like a really basic solution, which produces like what were described as putrid, like corpse-like fumes. Delightful. And then like basically like beating and hitting that liquid to aerate it until like you can separate out powder, like really hard and over a long time. So not super easy to just get a little bit of blue powder from these plants. Another option was Tyrian purple, also known as Phoenician purple. So that's the one that we've had since the ancient Phoenicians. That would show up a lot as sort of like royal blues and purples used in kind of like the garments of the royalty. And that one is derived from secretions of the Myricidae family of predatory sea snails. That can be accomplished either by milking them, as it's called, to collect their ooze, or by like crushing them. And then in that case, it's not renewable because the poor snails have been destroyed. But in terms of like how many snails you actually need to derive like significant amounts of Tyrian purple, the measurements I was seeing were in the realm of like a few thousands just to dye even like a trim of a garment. So you can imagine that takes quite a bit of labor too, and hence makes sense that was a very exclusive dye for a very long time. But the gold, or I guess gold blue standard, blue gold standard, whatever, was ultramarine. Now that was a pigment that's derived from powder ground from the very deeply blue-hued type of rock called lapis lazuli. And that's, it's one of my personal favorites, not that I'm biased, but lapis lazuli is super cool. It's been found in artifacts dating back to like the 7th millennium BC in the Indus Valley. And although now it can be found in some areas all over the world, for a long time it was sourced from the Sari Sang mines of Afghanistan, and then used across ancient civilizations in China and Egypt and the Caucasus, and then eventually spread further to Europe along the Silk Road. So similarly, as you can imagine, extracting ultramarine, also not super simple because you are literally grinding a rock into a powder. And what's more, because the sort of blue tone actually comes from a mineral called lazurite that's in lapis lazuli, and it's not the only mineral that's in the rock. There's also a lot of like boiling and purification steps that had to happen as well just to isolate that particular blue pigment. So again, kind of a pain in the butt to make, and also had to go a really long way. But all of that travel and toil proved worth it because basically once traders began importing ultramarine basically once traders began importing ultramarine to Europe, like on ships to Venice in the Middle Ages, it quickly became like the pigment to have among Renaissance painters.
Oh, you must try the lapis
Honestly.
lazuli.
Oh, no, for real. I mean, like,
It's the pigment
Pantone
of
color
Yeah.
at 1488.
yeah, exactly. And there was good reason for that. Like, it was a really, like, uniquely vibrant and, like, brilliant blue. And more of, like, a true blue, whereas, like, some of the other pigments around that I mentioned were kind of, like, greenish-y tinged. But also, this was around the same time that, like, depictions of the Virgin Mary draped in, like, bright blue robes were very in style. So naturally, the painters were like, well, my Virgin Mary's robes are going to be the prettiest blue, so I have to get this ultramarine. The only problem with that is that, so again, you have this like very rare, very difficult to obtain, highly coveted pigment. It was insanely expensive to the point that most painters wouldn't even like attempt to use it unless it was for like a commissioned piece from one of their patrons that they actually could like make sure they could front the cost of it. And even plenty of patrons would actually purchase their own stocks of ultramarine and like ration it out to painters for particular projects because it was just like so expensive and hard to come by. So given this, as I said, for much of human history, blue pigments were really only obtainable from nature over long distances after beating like smelly leaf juice, milking thousands of snails, or grinding rocks into a powder. Not super ideal. But that was until a paint manufacturer and a sloppy pharmacist made a chemical whoopsie that would change the world forever. So...
A sloppy pharmacist.
Yeah.
That's like a good bar name, I think.
Ooh.
The sloppy pharmacist.
I like
yeah.
that.
Yeah.
So Prussian blue, or its story, as I mentioned, began back in the early 18th century, estimated about 1706, when, as far as I can tell, every chemist was an alchemist, just like in this time in history. And paint maker / alchemist Johann Jacob Diesbach one day realized that he was out of potash, which was something that he needed to mix with iron sulfate and some cochineal beetles to make a red pigment called cochineal red lake. So he went and got some potash from pharmacist / alchemist, again, everybody was, Johann Conrad Dippel, whose reputation for carelessness and subpar quality wares was known to Diesbach. But, you know, the guy was just down the street, and sometimes you can't beat convenience, you know? I don't blame him. But so Diesbach, got his potash, went to go make his paint, following his usual recipe, but found that it turned out kind of a pale, like dull pink instead of the usual deep red. So he was like, well, maybe it's just diluted or something. So concentrated it, then it turned purple, kept concentrating, then it turned deep blue, and then he was like, Dipple. So turns out that, yes, Dipple screwed him over by selling him some contaminated potash, but that cloud had a Prussian blue lining because that's what he'd actually made. Prussian blue, also known as ferric ferrocyanide, also known as the first synthetic pigment ever created. So nicely done. So the recipe for it was like sort of published in a scientific journal in 1724, like about 20 years later. And then by 1750, it was being manufactured all over Europe and sold at 1/10 the price of ultramarine. So like it changed the game in terms of blue pigments that were available. And because of that, it was pretty much like an instant and lasting hit. It's a really nice, cool blue. It could produce a variety of tints and mix really well with other pigments. So lots of artists were attracted to it, like Japanese woodblock artists, as I mentioned at the top of the fact, as well as Van Gogh, Monet. And it was even the blue in Picasso's blue period. So it's just been pervasive ever since. Its cheapness and the kind of easy scalability also made it a popular choice for manufacturing and textiles, and that it gained its actual name because it dyed the coats of the Prussian army for a long time. And also, as like a fun side fact, so the Crayola crayon color Midnight Blue was actually originally Prussian blue. So if you have some crayons by you and want to draw that out, then you'll see it. But they changed the name to Midnight Blue in 1958 because they were like, there's no Prussia anymore. No one's going to know what this means. Another cool thing, again, with Prussian blue sort of being more accessible, we could, people could study it more, better understand its chemistry. And over time, it also proved to have a range of uses that were beyond just being a pretty blue pigment. So, for example, French chemist Pierre Macaire found that heating it yields the acid hydrogen cyanide, aka cyanide. So that was actually how we found cyanide, through Prussian blue. And that's actually why cyanide is named that as well, because it comes from a blue pigment. But yeah, Prussian blue is also really good at binding positively charged metal cations, and is itself harmless to ingest. That being said, don't go home and eat a bunch of it. Just don't do it unless, you need to, and you'll know why momentarily. But because of those facts, it's given to patients who've ingested toxic heavy metals like thallium or radioactive cesium to basically soak up those metals so that they can kind of pass more quickly through their GI system and be expelled without poisoning them further. And then when that happens, the poo is a very bright, alarming shade of blue. So hence... Prussian blue poo.
It's pretty alarming if it's any unusual shade.
Yes, true.
I think
It calls back the Frankenberry.
Well, didn't you,
Yes,
Rob?
exactly.
Yeah, Frankenberry's stool. Rob,
Yes.
do you want to explain what we're talking about to Latasha?
Natasha, I don't know if you've ever enjoyed Frankenberry, the kids' Halloween themed cereal.
I've seen it, but I haven't enjoyed it.
You've never seen it like this.
So, unlike Boo Berry and Count Chocula and all the other Halloween themed cereals, this one contained some kind of element, and I can't remember which metal it was, but it was a hot pink that they used to make Frankenstein's head look pink and berry-like, and it was preserved and undigested in children's stool, and so kids would be rushed to pediatricians with bright pink stool. And doctors are like, what's going on? And there's a paper that came out, a medical paper about Frankenberry's stool. If kids eat this breakfast cereal, it just turns their poop pink.
Oh, nice.
Yeah.
Okay.
Good times. I feel like by the end of this, a fax machine will have run the full gamut of situations where poo has become discolored in in unusual ways.
So I have a friend or colleague from Weill Cornell who published a children's book about the different colors urine can be.
Oh.
Yeah, and I will find the name and I will.
And then on the bottom there was a reader review. It says, "You're in for a treat."
This week, I learned about a dye that I used all through grad school and at BioBus called safranin. And that it is not the same as saffron.
Oh.
So, things some people might have thought for a second there, maybe for several years even, but
but not while you were working at BioBus, right?
Oh, no.
No.
That definitely would have come up in the interview.
Yeah, definitely.
So one of the nice things about working at BioBus is putting cool slides under the microscope and showing these really awesome samples. And I have been just toting around this literal box of mouse knees for the last 5 years. And I think everyone at BioBus is like, there goes...
Yeah, they're a big hit. Of course. Who doesn't have mouse knees in their back pocket?
There goes Rob with his mouse knees again.
Yeah.
And just... And it's in tons of videos now because in the last year we've recorded everything, so that they're everywhere. And thanks to my graduate mentors and the doctors at Weill Cornell and Hospital for Special Surgery for preparing and releasing those samples with me. But there are two states there.
They were like, "We don't want these mouse knees. Will you throw these away?" And Rob goes,
"Take them off our hands."
Yeah,
Throw them away.
Oh my god.
But no, so they're really nice samples because there's really good architecture of the bone and the soft tissue, and the staining is so bright. It's this really incredibly bright staining that looks at the bone tissue and the soft tissue, and it comes out in two shades, red and blue. And the blue kind of stains a lot of the bonier tissue, but the red does this really great job of staining the cartilage and the growth plate, which is one of the most kind of important parts of long bones. And so I use it all the time as a teaching tool. And people always ask, like, wait, what is this dye? And I'm just like, oh, it's saffronin. Wow, blah, 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 saffronin. And
Where'd you get these mouse knees, they ask.
that's probably the first question. You're right. But so I'd been using these in the context of mouse knees for a long time. Then I started teaching microbiology, where we do gram stains on bacteria, which turn bacteria either purple or pink based on what their outer shell, their kind of cell wall, is made out of. And we did endospore stains to see if bacteria would make spores that could be resistant to UV light or temperature. And we also used some analytical chemistry to check on reactions. And all of these things use saffronin. Saffronin is one of these like really kind of all-purpose dyes. And in the scientific community, it's probably in the top 10, maybe top 15 most popular dyes used for like all different purposes and all different types of labs. And so I was really interested to see, what does it even do? Like, how does it work? Why do I use it for cartilage, but they use it for like gram-negative bacteria, but like they use it for mast cells, which are like white blood cells that are tissue specific. And how can it do all these things? So I really went down the saffronin hole. And the first thing I want to point out is that it's in my thesis defense in the printed version, and I spelled it wrong. So, and the good news is that at least like online in several places, it says like saffronin, parentheses, often misspelled saffronin without an E at the end. So it's SAFRANINE. And the INE is actually important chemically because, so it's probably saffronine actually.
Or saffronine?
Saffronine. But it's got an amine group in it. And that's actually one of the very important chemical things about this, is that it has this nitrogenated ring. But so it's a positively charged basic dye. It adheres to cell membranes, so that's why it works in bacteria. It sticks to the cell membranes after for gram-negative bacteria because they have thinner cell walls. It also binds to nuclei, so it's used in viability staining. So things that are alive, they kind of push it away. Things that are dead, it seeps in and it stains the nucleus red, so you can see a big red mark where your cells are dead. So it does a lot of things using the kind of same chemical properties, and it's just allowed into different tissues at different times, which I think is pretty cool. So it's pretty universal, and it's made its way into a lot of different fields of biology, which to me means it has to be kind of old. And I went back to kind of the first description of saffronin in scientific literature. And so saffronin is either saffronin O or phenysaffronin is kind of the name of these dyes that are used in lab. And they're a big family of chemical moieties, or chemicals that can be used. The first one, or kind of like maybe the original one, was called mauvine, because it made a nice mauve color. And this is, I think, kind of where the interesting story starts. So mauvine was discovered by this guy named William Henry Perkin. And he was not trying to make mauvine. He was not trying to make a dye. Perkin was actually trying to make a malaria drug, quinine. And Emily, I guess you have stumbled upon this story before.
Go on. Yeah, it's a great one.
But so
y'all have knocked out two of my questions.
Booyah!
Oh, no. I mean, yes. For us, anyway.
But so in the process of making quinine, which has a quinolone group, which is similar to the structure of this chemical. And I'm sorry, for those of you who don't picture chemicals in your head, like me, these words are meaningless, but I'm just repeating them. But so he was heating up this starting point chemical with potassium stuff and sulfuric acid, and he essentially got this mauve-colored powder by mistake. He made like some small error. And I was thinking to myself, that must have been a crazy experiment when you expect to get a malaria drug and you get this bright purple powder. And so I checked, and that happened in 1864, and he wrote a paper about it. And then in a subsequent paper, he described getting from there to the creation of saffronin. And so I want to read you a quick excerpt from his 1879 Journal of the Chemical Society paper, which begins, "In 1864, I gave an account of some experiments I had made on the crystallized coloring matter which had been obtained from the commercial mauve dye of aniline purple. I then stated it contained an organic base having a formula that I will not repeat. Since then, I have at various times made experiments on this product, and I now beg to lay before the society the principal results that I have obtained. And then he presents 10 pages of basically, first I mixed it with this, and this happened, and then I mixed it with this, and this happened. Mm-hmm. And, like, he has all the stoichiometry, but, like, kind of no measurements, just, like, it turned this color, and it looked like this, and it was really cool.
Man, it was so easy to publish back in the day.
Right?
Honestly. Apparently you just have to beg? Like, who knew?
And then after 10 pages of that, he gets to saffronin, the one that I cared about. And he's like, I've already drawn attention to the existence of this dye, differing from mauveine in its solubility. But he says, I have made many experiments on this subject and give an example of the processes for its isolation. And then 10 more pages of, first I mixed it with this, and this happened. And just, like, it's literally, like, I work with high school scientists now and, like, high school students doing science projects. And this is the process. What if you heat it up? What if you added acid? What if you added more acid? Just like...
Yeah.
And then my favorite
Should we taste it before or after we add the acid?
But my
Can we stop the bus? The acid is going to spill.
Just put emoji. It's the same thing.
My favorite is his conclusion, which is, it, like, comes right at the end of a result. Not like, you know, the end of a discussion, but just like, then I did this and this happened. I bring these forward merely as suggestions. Experiments alone can settle the true constitution of these bodies. I am at present making some more experiments on the acetylate replacement derivatives of mauveine and saffronin, which I hope will throw a little light onto the matter. Done.
Mic drop. Oh my gosh. Yeah. I have to say, like, not... So, as part of my fact, which I was like, I think we've done enough, so I didn't go into it, but I also read Sir John Herschel's paper, wherein he published, like, the cyanotype process. It is ostensibly the same. And also enjoyed, like, oh, this is what this looked like. But also, I don't know if this was the same for the Perkins paper, too. It was very sort of narrative. Like, he really inserted kind of himself into the paper a lot and sort of, like, described his reactions to the chemical reactions, which I thought was nice, where it's like, oh, like, this, what was it? I think it was kind of like, oh, like, this sort of, like, peculiar, like, capricious reaction produced with, like, it blue with the most remarkable shade. And it's like, I kind of wish we still sort of use that language. It's just, it makes it a little more compelling.
When chemists were, like, sommeliers.
Exactly. Exactly. But it was also, like, similarly very long-winded.
Yeah.
Oh.
I like what you said about chemists being kind of like sommeliers. It'd be like, this acid has a... When you taste it, you get a distinct waft of regret.
This is a
terroir of excruciating pain.
This is an impetuous blue that makes me feel burnt inside.
So when I think of tie-dye, I think of the 60s and the summer of love. For some reason, that's when I thought it all started. Fun fact about me, I love tie-dye, but my love for tie-dye wasn't truly acknowledged until I went to the music festival, The Gathering of the Vibes in Bridgeport, Connecticut.
Ooh.
This was an annual music festival with arts and camping. It was 4 days, and it was filled with people who used to follow the Grateful Dead and their kids, and their kids. And you can imagine when I went on that fairground, and there was an explosion of tie-dye.
Wow.
The first day, I was like, I found my people. I was so happy. And I immediately went to buy a whole tie-dye outfit. So needless to say, I have a significant amount of tie-dye now, and I may be representing right now while we're talking.
And Rob is too. I see sucking up to the bio box.
Yeah, exactly.
Is that a bio box shirt you're
It's
wearing?
actually another science outreach company.
Oh.
Yes, it's
And
rocket.
I have the
Yeah.
same
Uh-oh.
one, but I'm not wearing
Saturday
it right
night.
now.
That's okay.
Yeah.
It's okay because I
And the
have one
beanie.
too. It's fine. It's okay. It's all together, you know? So I was really excited to dig down deep in the history of tie-dye. But guess what? I found out tie-dye started in Asia.
Oh.
So there's also some surviving pre-Columbian examples in Peru around 500 AD to 800 AD. But this was a little bit before Jerry Garcia and the Grateful Dead. So as we heard earlier, you know, in olden times, people used to use dye for berries and leaves and roots and flowers to color their clothing. These natural items were boiled and the fabrics were soaked in hot dyed water to take up the new colors. So let's talk about tie-dye. So in Southwest China, the Bai people have been tie-dyeing their clothes with a plant called woad, also called Astral Jerusalem, for over 1,500
Oh,
years.
Whoa.
Whoa.
Yeah, there it
Oh, yeah, woad. So it's similar to indigo, but it's a low concentration of blue pigment. So they pick these leaves from these plants and they let them ferment for 2 to 3 months and then they extract the dye. So I always wonder, like, who was the first one? Why did they even think to put this on clothing, right? It was because they used this herb to make teas. And then the farmers also got it on somebody got it on their clothes and they were like, oh, it's staining my clothes. And he was like, oh, I can turn my whole clothes blue, bro. He's like, let's do this. And
I love it.
so the Bai people love white and they love blue, this specific color blue. So they make these intricate plant patterns that reflect the nature, like fish and flowers and butterflies. And what they do is they sew these patterns into their fabrics. And sometimes these are very intricate patterns. And sometimes they take up to 10 days to sew. And then they kind of bind it all together, throw it into the woad dye. And then what comes out is this striking blue and white, amazing designs that are kind of embedded into the fabric. And different groups have different patterns that they take. So it's really cool. So similarly, in central Japan, there's a city called Arumatsu. So the people there, they practice shibori. So it's very similar.
Shibori is beautiful.
Yeah. So this shibori, so this is an ancient technique to manipulate the fabric. So this technique involves stitching elaborate patterns and then tightening and gathering the stitching before the dyeing. And then they form intricate patterns. Sometimes it's like origami, and then there's all these folds that have to happen. And a lot of these people have been doing it for 30 years. So you have to really be into it to like keep this going. And then what comes out are these amazing designs that are featured on the cotton fabrics. But now they're transitioning and expanding it to non-conventional fabrics like polyester and cashmere sweaters, which I'm thinking about going to Japan. Yeah, like a little son coming back, feeling fancy. So, but these things have been going on for at least 1,000 years. So so I've talked about China, I've talked about Japan, and now I want to talk about India. There's evidence as far back as 300 BC, as Alexander the Great mentions in his text, the beautiful dyes he encountered in India. So dyes in India have held a deep meaning for thousands of years. So brides have traditionally worn the Bandhani sari. It's the oldest method still in practice, and it's used to make saris and turbans. So Bandhani comes from the word bandhan, which means tying up, the technique that is used to make different patterns. So people wear a unique pattern that identifies them as a member of a particular community. So the patterns are important, but also the colors that the patterns. So traditionally, there's only 2 colors used at a time. So the colors are normally yellow and red, because those are the lucky colors in Indian culture. But in modern times, we got a little relaxed. So now we have yellow, red, greens, and pinks, and various shades are used. But the yellow and red still have strong cultural meaning. The red represents a bride or a woman who's recently married. And the yellow is used for a new mother. So I want to step back here. Just kind of nail home the fact that tie-dyeing is resistance dyeing, meaning that the fabric is resistant or not exposed to the dye. And this is caused by manual manipulation of the fabric. So all the tie-dyeing that I've talked about before has involved either sewing in a pattern, folding, scrunching, and then binding the material before the dye. But I'm going to tell you a new one. So yay!
New technique.
Taking mental notes.
So in Indonesia, they have their own form of tie-dye. It's called batik. So if you're from Indonesia, I'm probably going to say all these words wrong. But okay, just anyway.
Doing our best to learn.
That's awesome.
Yeah, doing our best. So batik is an Indonesian technique using wax-resistant dyeing applied to the whole cloth. So this technique originates in the island of Java, Indonesia. So batik is made either by drawing dots and lines and circles of the resist, which is wax, or printing on the resist with a copper stamp called a cap. So the patterns are placed on the fabric before dyeing, and then the fabric is dyed and then removed, and it produces the stunning images that you have to look up. You'll see them, they're really awesome. Yeah. So in the west coast of Africa, in the Gambia, they combine these 2 practices. So the Gambia uses kola nuts. They make a rich orange-brown color for fabric, which is different from the blues that we've all talked about before. So they come from the tree Kola natida. And these nuts are used as stimulants. So you can chew them to counteract tiredness, thirst, and hunger. And I kind of wish they were in the deli so I could check them out.
What was the name of it again? Because did I hear cola?
Cola
okay,
nuts.
so it really is
Cola
like
nuts.
the same thing,
Yeah,
Coca-Cola.
it's like, cola, come on. This already, marketing, I can, right? So in addition, they use indigo, which we heard about before. So the traditional leaves from the indigo plant are pounded into balls, which are soaked and mixed together with a caustic soda. The liquid is made from the roots from the local wanda bush, and the dye is tested by tasting. Yes, you heard. Very tasting, and also by sight. So these indigo dyes have been used for centuries in Africa to dye the cloth, but the extract recipe is a normally family secret that's passed down from generations to generations. But I love that about that, because we're all like, oh, indigo, but indigo's a little bit different. Everybody's got this family secret, so that's
So it's not
think
like
that's pretty awesome.
not a big corporate dye, but it's kind of an indie go.
Yeah, it's kind of an indie. I love it. It's kind of indie. Yeah, I love it. And also, what's cool is that when you drop the cloth into the indigo dye, the cloth appears green, and it will only turn blue and once it reacts with the oxygen in the air. So, the addition to all of these pigments, from the kola nuts as well as the indigo, they also use the batik style. So this results in a beautiful, intricate, multicolored patterns. And some people think that these patterns inspired the countercultural patterns that we associate with the 1960s. So it may surprise you, but the first evidence of tie-dye in the United States was in the early 1900s. So Charles E. Pellow of Columbia University. He acquired some samples of tie-dye muslin and subsequently gave a lecture and a live demonstration of the technique. But tie-dye didn't climb to mainstream popularity until the 1960s. So Bob Weir, he was the drummer of the Grateful Dead. He met this. I kind of know too much about the Grateful Dead, is what you're saying.
Oh, yes.
He's the one with no ice cream flavor in it. That's.
No. This is another.
Oh my gosh.
There's not Cherry Garcia. This is Jerry Garcia. So Bob Weir, he had a barn. He invited people over, and he met this guy, Courtney Pollock, who was an Englishman who came over to the United States, and he was an artist. And he showed him some of his work. And Bob was like, this is pretty awesome. So he commissioned him to tie-dye the backdrop for the Grateful Dead. So Courtney Pollock became super famous because he did all of the staging for the Grateful Dead, including the speaker fonts. Then he started doing tie-dyes for the band, and he did mandalays. So basically, Courtney Pollock became super famous because of that. And in his own words, he says, my journey began during the psychedelic era where vibrant colors and a free spirit were combined to create fun and whimsical clothing and dynamic art.
Nice.
Very cool.
Nice.
So this is also, it's pretty cool. So it was a time for innovation in the tie-dye scene. This other guy who's also super famous and is still doing tie-dye, his name is Paul Kenny. He just describes himself as a deadhead who used to follow around the Grateful Dead and sell T-shirts at concerts. It's really inspiring the next generation of tie-dye people. So if you see tie-dye with those small circles all throughout, that is Paul Kenny's signature on tie-dye.
Yeah, I've seen that.
And so now there's a whole new generation of tie-dye artists, from those who do it at Girl Scout camp to those who produce tie art and high-end runway shows. Like in New York Fashion Week in 2019, tie-dye definitely was shown. So tie-dye is one of my favorite things, and I hope that it's one of your favorite
Far
things.
out.
That's awesome. Oh my gosh.
Very cool.
So about one thing in the story, which was Charles Pellow. And so when I was looking for a fact, I was just kind of broadly sticking around, and I saw that, Columbia professor Charles Pellow, did some demonstration. And I was like, I wonder what that was like when he was just like that was like a lab demonstration. So
yeah, just a lot. I guess that I didn't read the paper, but that's what it said. He did a demonstration in 1900.
Gather round. We're going to demonstrate the new technique from.
I will say that, people used it in the 1920s as well, because it was like during, because people didn't have a lot of money, but they wanted to kind of spruce up their life, so people were doing tie-dye at that time as well.
The weird thing about Pellow was I was like, what did he teach? Was he a chemistry professor? So I tried to look him up in the Columbia website. I tried to look him up online. I could not find anything about Charles Pellow except 100 websites all about tie-dye. The only place his name appears is on tie-dye websites. And not that I don't.
This is legacy.
I just don't know where he exists. And so I did send off.
It's sort of like a Music Man situation, I feel like. It was in the Columbia class of 05, but it didn't start until 06.
Wait a minute. But
bye.
There are a bunch of pictures of him online, but I will say they all look not necessarily the same person. It's
he's just an urban legend now. He's no longer real.
Because I went into the New York Times historical website and looked up his name, and only 10 articles came up, and a bunch of them were obituaries, and they weren't for a Columbia professor. And then Theodore Roosevelt's obituary came up, and I read the whole thing, and he's not in it. But it was a really interesting read.
Oh, interesting.
But yeah, so Charles, if anyone out there knows about Charles Pellow, and like I may have sent a note to one of the historians at a Columbia library to see if he could track down professors from 100 years ago. I am so curious, who was Charles Pellow?
Really?
He loved tie-dye, man. Come on, bro.
Isn't that enough for you, Rob?
That's what he does.
Sorry, are you making it clear to your boss right now that you don't like tie-dye? Is that what... I think that's...
Okay, let's just say that is an interview question.
Yeah.
Or it used to be. Like, do you like
That's how you
tie-dye?
weed him out.
I did. That was an
It was,
interview
it was right
question.
before Do You Accept Hugs? And I was like, I guess. Yeah.
If I have
They're like,
to.
I don't know about this guy.
Oh, no. Oh my gosh, Latasha,
All
thank
right.
you so much for that fact. I can't wait to go back and re-listen to it and just like very quickly type like 30 different Google searches on all of the gorgeous like techniques and patterns you talked about. I love too with the sort of bi tradition that it just started with a guy spilling tea in himself and being like, nope, it's art. It's art now. It's intentional. I kind of just want to incorporate that and be like, I did not just spill this coffee. It is this is my coffee shirt now. This is my look.
I don't make mistakes. I make art.
There you go.
Well, there's now like Courtney Pollock. Some of his work is in art museums, and he sells prints for not cheap.
Well, if no, I don't have anything good, but I'm just gonna plow ahead and say a really dumb thing I'm have to cut out later. If somebody were to buy me one of those expensive tie-dye paintings and bring it to my funeral, I'd be a Grateful Dead person.
Oh, no.
Aren't you glad? Aren't you glad I plowed ahead?
I'm glad I passed it.
All right, everyone, and that means that we have finally reached our dyes and pigments and color origin quiz. That's right. These questions will all be about the interesting origins or sources for many of the dyes and colors that, in some cases, that we talked about. Unfortunately, in some cases, we did not, and I hope that you'll be enthralled by the unexpected answers. Question 1. What is the name of the pigment used for writing in ancient Greece and Rome, for drawing by Leonardo da Vinci, for toning photographs in the late 19th century, and for pretending that a picture of you is really a picture of your great-grandparent on Instagram?
Sepia?
Yeah.
The answer is sepia. Ding, ding, ding. So I'll give you a quick little bonus question. Sepia is the genus of the organism this pigment is extracted from, but what kind of organisms are these?
All right.
Actually, you're closer than you think. Yeah, they're cephalopods.
What? Oh, is this
Okay,
Yeah.
what I thought.
cuttlefish?
It is cuttlefish.
Hey!
But Latasha, amazing guess. Just
Nice.
nobody, like, of all the I literally didn't even give you animal.
Nope.
I just said organism, and you got very, very close with octopus. So well done. I'm gonna give Latasha the point there, obviously, because obviously I can't give it to Rob. He's not nearly high enough in the BioBus hierarchy. Yeah, so the answer is cuttlefish. And so this is among many other ancient dyeing techniques. This is one that, particularly in the Mediterranean, was used as sort of like ink for writing in Greece and Rome. And there are a lot of like Leonardo da Vinci like sketches and like a lot of his notes about different, inventions, but also just describing things. I saw basically him something he had drawn of like a water wheel, so like sort of like a power generating thing, not like a power generator, but you know what I mean, like using water to the flow of water to turn a big wheel that could then like mill oats or whatever I don't know. I'm my Renaissance Italian knowledge is pretty low, since one of the two classes I failed in college as may have been mentioned on the podcast before was early Renaissance art. The other one was organic chemistry.
Ooh, just polar opposites.
Yeah, I failed two classes in college. It was organic chemistry, 2 actually, and early Renaissance art from Giotto to Leonardo.
And I feel like the Venn diagram of those fields is this episode of Fax Machine.
Yeah.
Yeah, it basically is. I would say
Nice.
that it probably. I mean, my desire to take that class was very much in line with what this podcast is about being curious about things like well outside your area and being excited to learn.
Mm-hmm.
The harsh realities of that there were prerequisites for an upper level art history class taught by the department chair had not set in on me when I was a freshman, who was just like, wow, that sounds really cool. I would love to take that class. Turns out art history is really hard, and you have to take a bunch of the prerequisite classes to learn how to study, and I did not succeed. But anyway, Leonardo da Vinci used cuttlefish ink to make drawings. So question 2. Engineers in the UK made headlines across the world when they created one of the darkest substances known, using vertically aligned nanotube arrays to absorb around 99.965% of visible light in the right conditions. What is this material called?
Vanta Black.
All right, great team win there. So the answer is Vanta Black. But so another bonus question: what does Vanta stand for?
Ooh.
It's an acronym.
Very almost not totally. Oh.
It's so close. No, it's actually VANTA, not O at the end.
Yeah.
Sorry. So I would you be surprised if I told you I actually told you the full acronym already?
Oh, you said in the question.
I said it in the question.
I
What was it?
remember.
Do you listen to me? This is the ultimate test.
Oh, not that well. I mean,
Okay, that's fair.
Very-
Completely understood.
Very absorbent, not totally absorbent.
Okay, I'm gonna put you out of your misery. I am gonna file a report to your supervisor, Rob. Latasha, he did not listen to my question. I just obviously want to complain.
I'm
Have
writing
that
this
logged, please.
down.
Thank
Take
you.
a note.
Yes, Vanta stands for vertically aligned nanotube arrays, and it's just the structure of those absorbs a lot of light and minimizes the sort of like refractive scattering that can happen, and creates something that absorbs like just to a ridiculous degree under laboratory conditions, like as much light as possible. And it basically, like, if you coat objects in this, they appear flattened. Like they appear extremely dark, like a black hole where you can just see the outline of the shape. But one really interesting thing is in a 3D object that is coated with this, you lose all sense of the shape of it. Like you don't get any idea because there's no like sort of light and shadow playing with it. You don't get a sense of like, if you don't get the sense that if you were looking at like a bust or something, that you could see sort of the features of the face, even though they are there on the actual sculpture.
Wow.
So it's really amazing to like just go through pictures of this technology. And as you can imagine, so this material has many interesting engineering applications, but perhaps made the news really more because of its applications in art. So I think maybe a lot of people have heard about how the artist Anish Kapoor purchased like the exclusive license to the process of creating Vanta Black, or at least for its use in art, and it's also known as Blackest Black. Meaning that only he could use it to make art, and so other artists were not thrilled with this decision because it was such a transformative new color for people to play around with. Nobody could get a hand on it, and one in particular, a painter named Stuart Semple, was so motivated to draw attention to what he viewed as this artistic travesty that he created his own pigment. But this one, at least at first, wasn't black. It was actually pink, and he called it Pinkest Pink. So he offered it up to artists to use on his website with one single restriction. Quote, "By adding this product to your cart, you confirm that you are not Anish Kapoor. You are in no way affiliated to Anish Kapoor. You are not purchasing this item on behalf of Anish Kapoor or an associate of Anish Kapoor. To the best of your knowledge, information, and belief, this paint will not make its way into the hands of Anish Kapoor." So he was very, very motivated. And I will add that Anish Kapoor somehow, imagine that, did get his hands on it. Literally, when he took a picture and posted it to Instagram of his middle finger dipped in the pigment with the caption, like a profane caption, you can kind of imagine. And so in response, Stuart Simple actually made a very, very black pigment that could be used in paint, and had a lot, just sort of out of revenge, kind of like made something that was maybe not quite the same physical properties, wasn't like as like superlative in all these sort of like nanotube like features, but nonetheless was an extremely useful, a very, very dark black pigment that could be used in paint. Like I think it was actually quite difficult for Vanta Black to be used in, was non-toxic and Vanta Black wasn't, and had a lot of other desirable qualities. And so I feel like the whole art community really rallied around him and it was just kind of a fun story to follow.
Artists throwing shade.
Literally. Yeah, nice.
Were they able to buy and sell that second black paint, or did it have to be sold on the black market?
Very nice.
Oh, I also feel compelled to add in that like highly absorbent sort of shades of black occur in nature as well, including in some species of birds of paradise. To bring it back,
yeah,
I'll never not be obsessed.
This is one of M's favorite topics right now, as you may have heard in our recent episodes. And I'm still very convinced you need to do that for a Halloween costume for our Halloween show.
Like I said, I was already 99% there, and it was just kind of like, I mean, literally,
You were 99%
tipping me
invisible?
over the edge into being like, I'm absolutely doing this, was just kind of like, knocking over a domino. It's happening.
We're doing
happening.
it. We're doing it. Get excited for our to-be-announced Halloween live show. All right.
Oh, was it Frankenberry pink?
Not a lot of people knew this, but Pink is Pink was actually created from Pooiest Poo.
The only problem with it was the stinkest stink that came with it.
Yeah.
Oh, jeez. Okay.
Okay, so question 3. A pigment derived from what taxonomic class of organisms gave the robes of Catholic cardinals, the uniforms of the British redcoats, and Starbucks strawberry frappuccino their distinctive red colors?
It's the Beatles, but taxonomic.
It is the cochineal.
Oh,
yeah,
it's just
they're
those
not-
guys. Oh, yeah.
Well, I'll tell you, so the taxonomic class is insects. So you went straight to the exact answer, which is cochineals, which are not technically beetles, but they are colloquially called beetles. And they are, and these particular ones that I'm talking about are parasites of the pads of the prickly pear cactus. Yeah. So they live like roughly from Peru up to like the southwest United States. And these insects are sessile, which means that they lack a means of self-locomotion. So they basically just kind of sit there on cactus pads and munch, just all day long, just munch on cactus pads. Ooh. And if you're just sitting there and you have no means to move around, you would be probably pretty concerned about literally any animal or organism just walking right up that aren't sessile and just jumping on you. And the way they prevent themselves from being predated upon is that they produce astoundingly large quantities of a chemical known as carminic acid, which deters predation by other insects. I think people have tasted it and they think it's because it's just very bitter. It's sort of that normal thing, like you taste real bad so things won't eat you. And it accounts for, and this blew my mind, carminic acid accounts for up to 25% of the dry weight of this animal.
Wow.
Which is a lot.
Yeah.
So it basically makes a lot of it, and carminic acid happens to be red, so it can be used to create this dye carmine, which has this really nice red color, and actually had been used by the Maya and Aztec peoples as far back as like the 2nd century BCE, and then during Spanish colonization, it was the second most, like, basically it says here second most valued export, but with any sort of colonization related process, it is more like the second most valuable like extraction, but next to silver, which obviously Spanish colonists valued a lot, and which was something that was weird, is it was apparently unknown in Europe that the dye came from crushed up insects until like the 18th century, which is because I don't think it was a secret in Mexico, which is weird. I just think that's like strange, but basically you can imagine like all these like Catholic cardinals, and then sort of the noted colonialists themselves, the British Army, and then also Starbucks, which I'm sure are thrilled to be listed in that. I'm sorry, another enemy of the pod. Yeah.
Nice.
Sorry, Rob, are you going to say something?
I was just going to say product labels back then were definitely not what they were today. So, informed consumers were in a tight spot.
Well, it's actually listed in like ingredients as like natural coloring, like 4, I think, or some number.
Red 4.
But
Red
it's
40,
just
I think. Yeah.
Yeah, something like that. But it's listed under, at least for a while, it was just under like natural colors, which doesn't really give like the same impression of like crunched up little cactus bugs. But honestly, I don't find that as offensive as apparently some people seem to. But this Starbucks actually had to pull or at least change the ingredient that was the red in their strawberry frappuccino because people were concerned. I think it was sort of more about animal welfare. It was like that the strawberry frappuccino wasn't vegan was sort of their more concern. Although I think that in the frappuccino there may be ingredients like I think maybe milk probably. I don't know.
Of higher concern.
If they were getting like an almond milk version and thinking they were in the clear, then
Maybe, yeah, exactly.
could be.
It is probably a little concerning that when you're using a very red fruit to make a drink, that then you have to add a red dye to it. But look, we're a simple podcast, and that's outside the remit. So I'm just gonna press on to question 4. Question 4. In ancient Mediterranean civilizations, titanic quantities of marine snails were harvested, dissected, and left on the beach to rot in order to produce what color associated with royalty in antiquity?
Oh, that's a stumper.
I wonder if you know this one. I spend all this
familiar.
time trying to come up with good, fun questions for you, and then you go ahead and you just ruin it right in the thing. Why are you so good at researching is my question. So what's the answer?
I don't want to guess because I'm going to mix up the purples. That's what I'm going to do. So I'm just going to sit back and wait.
I admittedly got so embroiled in being like, oh, I know this question. I know all these clues that I forgot what the question was actually asking for. So can I get a partial repeat of the question?
Oh, I'm sorry. All I'm hearing is you don't know the answer. So I'll just go ahead and tell you,
There
and
you
you get this
go.
one wrong.
All right.
Wait,
Okay, so
can I guess though? Because you're asking for
the one about marine snails. Tell me the dye.
Oh, the dye. Oh, the Tyrian blue or
Tyrian
purple.
Tyrian purple
Yeah.
in particular. Yes.
Yeah.
So
Different
the color is
snails,
purple.
different shades, but yeah.
So this is purple, specifically Tyrian purple, and it's actually named after the Phoenician city of Tyre, which is in present-day Lebanon. But according to David Jacoby, the author of Silk Economics and Cross-Cultural Artistic Interaction, quote, 12,000 snails of Murex bandaris yield no more than 1.4 grams of pure dye, enough to color only the trim of a single garment.
Yeah, that was the
So-
figure I saw.
Basically, it was extremely difficult to produce, and the yield was very low. But it was also extremely valuable, about 3 times the value of gold. So there were these giant stinky beaches, basically, where all these animals were just dissected and then either left out, or I think the hypobrachial glands is sort of the ink-containing gland or ink-secreting gland. That they boiled in these giant lead vats to extract the color, or to extract basically the chemical compounds that then when they were treated with heat and acid could turned into the purple color of the dye, and it made for this very beautiful color, purple, but also for a very stinky Roman emperor. But of course, who was going to tell them? You know what I mean? Right? And the connotations of wearing purple were jealously guarded by some royalties, such as the Roman Emperor Caligula, who saw that a Roman client king named Ptolemy of Mauritania had entered a theater wearing a very fancy purple cloak and ordered him killed. Because
Yikes.
he dared to wear a fully purple cloak. And, for example, even Roman senators, I don't know about around the time, but Roman senators were allowed to wear basically, purple trim but not the fully purple cloak, or I get toga maybe. I'm not exactly sure of my Roman sartorial knowledge, but the sort of full purple clothing was reserved for just the emperor themselves. So another contrast to that, though, I thought was really interesting was the Roman Emperor Marcus Aurelius reflected on the meaninglessness of the trappings of royalty, saying in his Meditations, "This purple robe is only some sheep's wool dyed with the blood of a shellfish. There are things which appear most worthy of our approval. We ought to lay them bare and look at their worthlessness and strip them of all the words by which they are exalted. For outward show is a wonderful perverter of the reason. And when you are most sure that you are engaged in matters worth your while, it is then that it cheats you the most."
Zing.
So question 5, another one ruined by Rob. Coming to the rescue of...
Okay. Sheesh.
Completely ruined. Why are we even doing this? Coming to the rescue of marine snails everywhere, chemist William Henry Perkin accidentally created Movine, also known as aniline purple, while trying to synthesize the phytochemical quinine in order to treat what disease?
See what?
Malaria!
Yeah.
Yes. How did you know?
I am SMRT.
You just knew that. You definitely knew that anyway. So, of course, the answer is malaria. In 1856, William Henry Perkin was an 18-year-old chemistry student under the tutelage of the famous chemist August Wilhelm von Hofmann, and was given the task. Thank you very much. And was given the task of synthesizing quinine as a treatment for malaria. He did not succeed in developing a treatment for this awful disease, but one of his failed attempts did turn purple. So that's something, right? I guess it's not bad. A lot of people have gotten less. In fact, it actually became one of the first chemical dyes to be mass produced. And as you'll recall, since purple was such like a difficult color to get with the natural dyes that were available, now that it could be synthesized in these large quantities, everything started being made purple. In fact, in 1860, it was so popular that magazines described the throngs of people wearing purple clothing as, quote, like so many migrating birds of purple paradise. And a different one, quote, the mauve measles are spreading to so serious an extent that it is high time to consider by what means they may be checked.
Wow.
The mauve measles.
That didn't land. I feel like they could have done better.
Contagious purple clothing. I thought that was cool.
You can just picture a room full of old men in suits being like, "This is a plague upon our society."
Oh my God. See, I was picturing poor little 18-year-old William Perkins going to his PI being like, "So, I didn't make quinine, but
But bright side,
I made purple." Can I write my dissertation now?
get this mauve measle away from me. Anyway, so now we have question 6. Litmus is the name for the mixtures of different dyes used in one of the oldest forms of pH indication, i.e. the litmus test. But what composite organism are they extracted from?
Cabbage?
Oh, it's not cabbage, but
Okay.
good thinking.
Yeah,
Not necessarily close to cabbage, but I just kind of like the way you said it.
Yeah.
Composite organism. Yeah.
composite organism is an interesting one because
Yeah.
That's the main clue. I'll tell you that.
it makes me think of like, so that's like several organisms living together, like a lichen.
Lichen? Yeah,
Yes,
lichen.
the answer is lichen.
Nice.
And I actually thought you were going to get it a lot earlier in that sentence when you said it makes me think of like, and I was like, oh,
It's halfway there.
I did have 2 false likes in that sentence, including like a lichen. That one was intentional. The one before was not.
yes. So basically, there are a lot of dyes that are made up from just sort of like scraping off lichen, which you should not do because it takes a very long time to grow lichen. So don't do this. But it is true that there are dyes such as litmus, the one used for that pH indicator, a dye that changes color. One particular mixture changes color when it's exposed to a base, and one that changes color when it's exposed to acid. And they're derived from basically, mushed up lichen. I think that's pretty interesting.
You know, I learned that in Hamilton.
Oh yeah.
Yeah. Lit must be nice. Lit must be
It
nice.
must be nice to have lichens in your dyes.
What? Okay.
I'm sorry, Lin-Manuel. I know you're listening, and I know that hurt you.
As much as it hurt us.
So, question 7. Scheele's green was a pigment made from copper and arsenic and used to make beautiful green wallpaper in the 19th century, but also released arsine gas when it got wet or moldy, which is a small price to pay for beauty. But recently, it has been implicated in the death of what former world leader who did not say, "Able was I ere I saw Elba"?
Oh, really? That's Elbo's where
Napoleon.
Napoleon died.
That's true.
It wasn't an answer. And what Emily said was an answer. I just had a statement.
What did you say,
I
Em?
said Napoleon.
Yes, Napoleon is the answer. do you see, I was doing this sort of old trivia host thing of like, you're like, that's when Napoleon died. I'm like, sure.
I've heard that.
Yes, the answer is Napoleon. So, it has been suggested that he may have died from arsenic poisoning, potentially as a result of wallpaper, basically, and paint in general, containing a lot of really toxic substances, including arsenic. It is probably more likely that it was a lifetime long exposure to arsenic basically in wallpaper. And things like that contributed to his death. But people got really excited when a sample of the wallpaper I think it was his bedroom at the place where he was exiled to in Elba, and it was this green color that contained arsenic, and people knew this about Scheele's green and how dangerous it was. It was found much later, so people were thinking, oh my goodness, all these theories about the British assassinating him may not have been true. He wasn't poisoned. Maybe he just had touched his moldy arsenic covered wallpaper or something, but it was probably that Napoleon, and I'll say this is canon, Napoleon licked wallpaper his whole life. And that's what you get,
Just little elbow grease.
Yeah. So the final question.
Okay.
So question 8, dragon's blood was used as a dye by the Romans, sourced from the species Dracana draco on an archipelago off of the west coast of Africa. I have a very simple question for you. How did the Romans harvest dragon's blood? You should feel free to ask any clarifying questions. I can imagine there might
Komodo
be.
dragons, right? No. Okay.
No.
Gila monsters?
No.
I know they're like a real.
Okay. Did they
Sounds so
harvest
familiar.
it
No,
from an
I'm
animal?
talking about dragon's blood. I'm talking about dragon's blood from the species Dracana draco. I'm not talking about any like imitation dragons like those lizards. This is not a lizard.
I'm
This
trying
is
to imagine
dragon's blood.
dragons.
Okay. So
This is Dracana draco, which lives it continues to live to this day on an archipelago off the west coast of Africa. This is Fax Machine. I would not tell you that there's dragon's blood if there wasn't dragon's blood.
Okay.
so I'm guessing they did it kind of in private rooms, out of sight, with no witnesses.
Who has eyeballs?
I don't know. Eyeballs. Okay. No, this organism doesn't have eyeballs.
Okay.
Is it a plant?
It is a plant.
Ah!
It is a plant,
Is
and
it
that's good enough to get the
okay.
answer. I'll tell you it. So getting that it was a plant was the key part of this mystery.
Okay.
So Dracana draco is known as the dragon blood palm, or the dragon blood tree. There are actually two different species. One is in the Socotra archipelago. It was part of the Arabian Sea, it's in the Arabian Sea and part of Yemen, and the other one is in the Canary Islands off the west coast of Africa. And it is so called because of the red sap that the trees produce. And it was basically, interestingly, it was indistinguishable to the Romans or they had a lot of trouble distinguishing it from cinnabar, which it itself was used as a red dye and is extremely toxic. So I don't know. I mean, it's like I feel like this was the kind of thing where this was like a red dye that they thought was cinnabar but didn't kill you, and they used it just enough to like keep using cinnabar. They were like, surely the cinnabar won't kill us this time, and then they have that positive reinforcement, and then they go back to the cinnabar and it kills them.
Yeah, okay, we'll try you again in a few years.
Wow.
All right, so with that, that's our show. Thank you for listening, and Latasha, it was so wonderful to have you on this episode. Thank you so much for joining us.
This episode was to die for.
Yes!
Very good, very nice. And if you were Napoleon, you may very well already have.
I was gratefully dead if I was. So.
Hey.
Oh, the closure.
Amazing. Full circle. Love that. So is there anything you'd like to plug? Do you social media or BioBus links?
Yeah. Go to check out BioBus at BioBus.
Twitter and Instagram at BioBus.
It's at BioBus. I think that's all the Facebook, the social, Instagram. All of that. Go check it out.
Awesome. So if you want to learn more about this podcast, you can check out our website at faxmachinepodcast.com. And please follow us on all of our accounts as well. You can find us on Instagram and Twitter at FaxMachinePod and on Facebook at Fax Machine Podcast. And if you'd like to follow us individually, I'm at Arcs in Sciences. M?
At _EM Costa.
And Rob?
At Sweatervest SCI.
And just to reiterate, if you want to learn about all the cool stuff that BioBus is doing, you can follow their social media at BioBus. And if you think, wow, what an amazing organization, I love the idea of educating children about science on a bus full of incredible microscopes and Rob, you can donate to BioBus's incredibly important mission at donate.biobus.org. Fax Machine is produced by Noah Giberson, M. Costa, and Rob Frawley, with editing by Noah Giberson. Our theme music is by Anthony Antonelli, and our logo was designed by Mike Zola. Bye!
Bye!